we talked about scientific notation, and we learned how to write the digits and numbers with scientific notation in order to avoid mistakes and errors. We had the practices that I want to solve them for you. The first one, which is related to the addition and subtraction, as you remember, we mentioned that the exponents should be equal for the case of addition and subtraction. So in this case, for this digit, I want to make the exponent equal to this one. So I will write this number like that. I will move the decimal point one number to the left, and we have plus 1, which is added to minus 3. So it's like that. 0.41 multiplied by 10 to minus 2. So now we want to do the subtraction for these two numbers that have the same exponents. The final result is 1.81 multiply 10 minus 2. For the case of multiplication and division, it wasn't important if the exponents are equal or not. The only point is that when the exponent here wants to go up, the sign change from positive to negative or vice versa. So in this case, it is written like that. For minus 9, and the final result is 1.7 multiply 10 to minus 5. Let's go to the new lesson, scientific figures. Except when all the numbers involved are integers, for example, in counting the number of students in a class, it is often impossible to obtain the exact value of the quantity under investigation. For this reason, it is important to indicate the margin of error in a measurement by clearly indicating the number of significant figures, which are the meaningful digits in a measured or calculated quantity. When significant figures are used, the last digit is understood to be uncertain. For example, we might measure the volume of a given amount of a liquid using a graduated cylinder with a scale that gives an uncertainty of 1 milliliter in the measurement. If the volume is found to be 6 milliliter, then the actual volume is in the range of 5 milliliter to 7 milliliter. So when the uncertainty is 1 milliliter, you are not sure if you measured 5 milliliter or 7 milliliter. With a cylinder, for example, that has 6 milliliter in volume. So we represent the volume of the liquid as 6 plus minus 1 milliliter. In this case, there is only one significant figure, the digit 6. That is uncertain by either plus or minus 1 milliliter. There are some guidelines for using significant figures. We must always be careful in scientific work to write the proper number of significant figures. In general, it is fairly easy to determine how many significant figures a number has by only the following rules. Rule number 1. Any digit that is not 0 is significant. For example, if we have 845 centimeter, we have 3 significant figures. All 3 are significant figures. Or, for example, 1.25 3, 4 kilograms has 4 significant figures. 1, 2, 3, 4. Even the number before the decimal point, since it's bigger than 0, it is counted. Number 2. Zeros between non-zero digits are significant. Thus, when we have 606 meter, it contains 3 significant figures, or for example 40.501 kilogram. It contains 5 significant figures, 1, 2, 3, 4, 5. Rule number 3. Zeros to the left of the first non-zero digit are not significant. Their purpose is to indicate the placement of the decimal point. For example, 0.08 liter contains 1 significant figure, only 8. Or for example, this number 0.0000349 grams. It contains 3 significant figures, so we don't count the zeros before the non-zero digits. Rule number 4. If a number is greater than 1, then all the zeros written to the right of the decimal point count as significant figures. Thus, 2.0 milligram. It has 2 significant figures, or 40.062 milliliter has 5 significant figures, 1, 2, 3, 4, 5. And the other one, for example, 3.040 decimeter has 4 significant figures, 1, 2, 3, 4. All the zeros after non-zero are considered because they are written on the right of the decimal point. If a number is less than 1, then only the zeros that are at the end of the number and the zeros that are between non-zero digits, as I mentioned earlier, are significant. This means that, for example, 0.070 kilograms has 2 significant figures, only 7 and 0 are meaningful. Or 0.6002 liter has 4 significant figures, 1, 2, 3, 4, which is the based on rule that I mentioned you. When we have a digit which is lower than 1, so all the zeros that are on the right and between non-zero digits are countable. Rule number 5. For numbers that don't contain decimal points, the trailing zeros, that is zeros after the last non-zero digit, may or may not be significant. Thus, 700 centimeter may have 1 significant figure. It is only, if I want to write it, may only have 1 significant figure, which is only digit 7, or 2 significant figures, or 2 significant figures, which is digits 7 and 0, 70, or 3 significant figures, which is 700. We can't know which is correct without more information by using scientific notation. However, we avoid this ambiguity. In this particular case, we can express the number as the number 700 as 7 multiply 10 2 for one significant figure. So better to write it here. If we have one significant figure, better to write it like 7 multiply 10 by exponent 2 for one significant figure. For two significant figure, it's better to write it 7 multiply 10 2. And for the last one, better to write 0 0 multiply 10 2. For the three significant figures, if we want to avoid some mistakes, by writing like scientific notation. So, as an example, determine the number of significant figures of the following, numbers. Let's solve it together. For the number A, since we don't have any decimal point, we have three significant figures. Significant figures, because each digit is a non-zero digit. For the number 2, we have again three significant figures, because zeros between non-zero digits are significant. Just 0 between non-zero digits. And for the last one, again, we have 3 significant figures, because zeros to the left of the first non-zero digit don't count as significant figures. Here, this 0 isn't count as a significant figure. So for counting the significant figures, we only start from 8. 8, 2, and 9. We have 3 significant figures. Here is a practice that I'm asking you to solve it for the next session, and I will tell you the correct answer. Here we have some rules when we want to do calculation. How to handle significant figures in calculation. For the case of addition and subtraction, the answer can't have more digits to the right of the decimal point than either of the original numbers. For example, you want to do a calculation for an addition. Consider this example. 89.332 plus 1.1. The answer is 90.432. Consider that here we have one digit after the decimal point. One digit after decimal point. And we round off our answer to 90.4. Consider, here are some rules for round off. Consider, if the number here is less than 5, we don't change this number and we write it exactly as I did. But if this number would be equal or greater than 5, we will add 1 to this number. For example, for the next calculation that we have, minus 0.12, we have this answer. And here we have 2 digits after decimal point. So 2 digits after decimal point. And if we want to round off our answer, as you can see, 7 is greater than 5. Here, this 7 is greater than 5, so we will add 1 to this 7. 1.98. Regarding the multiplication and division, the number of significant figures is determined by the original number that has the smallest number of significant figures. For example, in multiplication, here, consider 2.8 multiply 4.5039. The answer is 12,61092, which needs to be round off to 13, because however the smallest numbers which are significant in this equation is 2. So our answer even should have 2 significant figures, and if we want to round off, we will look at the 6, which is greater than 5, so we will add 1 to 12, and we write 30 as the final answer. And for this case, 6.85 divided by 112.04. The right answer is so long, like that. 7, 8, 9. And it needs to be round off to only 3 significant figures, because here this number has the lowest significant figures, 1, 2, 3, and that one has 5. So we will consider the lowest one. And since if we want to write it like 3 significant figure, the significant figure is 6, 1, 1. And since 3 is lower than 5, when we want to round it off, we will write 1 and we don't add anything to that. So the final answer is 0.0611, which has 3 significant figures. See you next time.